Hello guys, in this video I'm going to go over chapter 8 worksheet. So there are a lot of videos under the chapter content, so please watch those videos to cover the topic. In here I'm going to go over all these questions for you to practice. So I want you to practice by yourself first and then watch the video here to see how it's done. And if you got it wrong, so you'll see how you get it correct. Okay, so how to get the molecular geometry of a molecule. So the first thing we are going to do is we're going to count the number of valence electrons. So number one, count total number of valence electrons. That's the first thing that we are going to do. Two, we're going to form the skeleton. 3, octet the outermost atoms. And 4, make sure all atoms are octet with an exception of hydrogen. Right? Okay. So these are the 4 steps we can follow, and then we can determine the geometry of a molecule. So let's work on carbon tetrabromide. So I assume that you know how to get the valence electrons now. You can look at the periodic table, or you can do the electron configuration. So find out the number of valence electrons. So this is carbon here. I get 4 valence, and then I have 7 valence for bromine. I'm going to do 4 times 7. So a total of, I have total of 4 times 7 is going to be 28, plus 2 is going to be total of 32 electrons. So here I have 32 electrons to construct my molecule. So what I'm going to do now, I'm going to write a skeleton. So now we're going to form the skeleton. All right, I'm going to have the carbon in the center. I'm going to have the bromine in the left, bromine on the right, bromine in the bottom, and bromine on the top. So if you have 2, you're going to just put next to each other. If you have 3, around the central atom, you're going to make a triangle. If you have 4, you're going to have a square like this one. Okay, so first we're going to make single bonds. So when we are making single bonds, every single bond has 2 electrons in it. So we're going to count 2, 4, 6, 8. So I used up my 8 electrons, and 32 minus 8 is going to be 26. I have 26 electrons left. 32 minus 8 is going to be 24. I'm sorry. So 24 electrons. So now I'm going to make octets for the outermost atoms. So which are the bromines, right? So I'm going to do 1, 2, 3, 4, 5, 6. So this is octet. So I have 3 pairs of lone pair electrons. I have 3 lone pairs electrons, and then I have a pair of bonding electrons, so it makes 8 in total. So 1, 2, 3, 4, 5, 6 lone pairs, and then 2 here is 8. Octet rule: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and 5, 6. So I got 6 times 4, 24, and I got 8 bonding pairs. It makes 32 total. So that's done. I run out of all my electrons. Okay, now I run out my all electrons, but also outermost atoms are there, all octet. So I'm going to look at the central atom. I have a carbon on the central atom, right? So carbon has 2, 4, 6, 8. So 8 bonding pairs, 8 bonding pair electrons, or 4 bonds in each. We have 2 electrons, so it's going to make it 8. So the carbon as well octet. So now we're going to do is, we got the dissolution structure. So now we're going to determine the geometry. So the geometry is determined by the number of pairs of electrons. So this is the one pair I have. This is another pair. This is another pair, and I have 4 pairs of electrons on a central atom. So once you have the 4 pairs of electrons on a central atom, the geometry will be tetrahedral. So that's going to be the geometry of electron cloud, as well as the geometry of the molecule, because all these electrons are occupied within an atom, right? So we have a bromine here, here, and there. So we have all these electron pairs are bonding pairs. So the geometry will be tetrahedral as well. Okay? That's how you do carbon tetrabromide. Okay, so let's do question number 2. So you can pause anytime. You can, practice yourself. So I'm just keep going, okay? So let's do xenon with fluorine. Okay, xenon with fluorine. How many valence electrons do we have on xenon? Is 8, right? And then how many on fluorine? We got 7. So I'm going to do 7 times 2. So total of 14 here, 8 here is going to be 22 electrons. So we have 22 electrons to construct our molecule. I'm going to have the xenon in the center. I'm going to have fluorine on the left. I'm going to have the fluorine on the right. I'm sorry, right on and left. So now I have 22 electrons. I found my skeleton. I'm going to make a single bond in between. So I used up my electrons, 4 of them. So I have only 18 left. So I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So here I use up 12 electrons, and then for 4 bonding pairs, it makes 18. I'm sorry, 12 here, 14, and 16. And I get 6 electrons more, right? So what I'm going to do with this, I'm going to dump all of them into the central atom. 1, 2, 3, 4, and 5, 6. So now we're going to determine the geometry of the molecule. To be able to determine the geometry of molecule, we're going to look at how many pairs of electrons we have on the central atom. I have 1 pair, 2 pair, 3 pair, 4 pair, and 5 pair. If you have 5 pairs of atoms if you have 5 pairs of electrons in a central atom, it's going to be trigonal bipyramidal. Trigonal bipyramidal. Electron cloud. So that's not the geometry of the molecule, that's the geometry of the electron cloud. So now we're going to look at how many of them are being occupied with an atom, right? So the one we are occupied is just fluorines, right? So 2 of them. So if you have a trigonal bipyramidal electron cloud and only 2 of them are occupied, it's going to be a linear geometry. Well, there are electrons, but we don't see them, right? We don't see them. So we just see the molecule, fluorine, xenon, and fluorine. So it's going to be a linear molecule. Give the number of lone pairs on this guy is going to be like around the central atom. So 1, 2, 3 lone pairs on this guy, right? So the linear geometry, 3 lone pairs. On the top one is tetrahedral, no lone pair on the central atom, right? No lone pair, no lone pair. All right, this is for xenon difluoride. So let's work on xenon with 4-fluoride. So we are going to do the same thing. We got 7 valence for xenon, and then we got 8 for xenon, and then 4 times 7 is going to be 28 plus 8 is going to be 36 electrons in total, right? Okay. So we got 7 times 428 plus 8 is going to be 36 electrons. All right, so what we're going to do, we're going to have the xenon in the center, fluorine around it, fluorine, fluorine, and fluorine. So I'm going to use single bonds to make bonds. I'm going to use this 4 bonds, which makes 8 in total. So I have 28 left. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So I used up my 24 electrons around to make the octet for fluorine, 24 right there, and then I get 8 for bonding, makes 32. I have 2 left, 1 here and 1 here, right? So the now question is how many bonding pairs, how many pairs of electrons do we have on the central atom? 1, 2, 3, 4, 5, and 6. Obviously, this is not an octet, right? This is an exception. So we got some exception cases. So I have 6 electrons around the central atom. If you have 6, it's called octahedral. Electron cloud. That's not the geometry of the molecule, right? Because not all these pairs of electrons are occupied with an atom. So the ones are occupied only 4 of them. So what do you call if you have 4 atoms around this octahedral electron cloud? It's going to be a square planar. Square. I'll be providing the geometry, so you don't have to memorize these names, okay? I'll be providing a table with all this geometry. So once you find out how many electrons you have, you can find out the geometry. So the geometry of the molecule will be square planar. And then now the question is how many lone pairs we have over here. We got 2 pairs of electrons, right? 2 lone pairs. It's not asking you how many electrons, it's asking you how many lone pairs. Each pair has 2 on it, so it's going to be just 2 pairs. Alright, so let's do this one. We have selenium, and then we have oxygen, 4 oxygens and 2 electrons on the charge. So selenium is an atom right under the oxygen. So oxygen under we got sulfur under oxygen, and then under sulfur we got selenium. So they're all going to have the same numbers of valence electrons. It's going to be 6, right? Okay, and then we are going to have 6 for each oxygen. So 4 times 6 is going to be 24, right? Okay, and 24. And also we have 2 electrons a charge. That's for the molecule. We're going to add 2. So 6 plus 24 plus 2. It's going to be 24, 32 electrons. We have 32 electrons to construct our molecule. So what I'm going to do, I'm going to do exactly the same thing here. I'm going to have the oxygens around it. And now I'm going to make a single bond first. 1, 2, 3, 4. I used them 8 of them, so I have only 24 left. So I'm going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So I used up 24 electrons right there, and I used up like 8 electrons for the bonding pairs. So I run out all my electrons, right? That's going to be the structure. Okay. All right, so this is question number 4. So this is, what is the geometry here? Well, we got, I'm sorry. What we have here, so we have here 1, 2, 3, and 4 pairs of electrons. So it's going to be tetrahedral, what's going on? Tetrahedral cloud. I'm sorry, let me fix this. Right. Cloud. And then we're going to have also tetrahedral geometry, right? Because they're all occupied with an atom. So tetrahedral molecule. How many lone pairs here? Molecule. Yeah. How many lone pairs we have here? Well, we don't have any, right? Because they're all occupied by an oxygen. So no lone pair. All right, so let's do the next question. It's asking you the same question. So we're going to have a chlorine 7 valence electrons, and then we have 3 times 6 plus 1, right? 7 for chlorine, 6 for each oxygen, and then we have a negative charge on it. So it makes 18 here, 25 and 26 electrons in total. All right, so I'm going to have the chlorine in the center, oxygen, oxygen, oxygen. I'm going to make single bonds. I used up 6 electrons. I have 20 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have 18 used up here, so I have 2 extra left, so it's going to be 20. So I used up all my electrons, right? So I look at oxygens are octet, and then the chlorine here octet as well. So this is done, right? Okay, so what is the cloud geometry? 1, 2, 3, 4. Tetrahedral. But one of these guys here are not occupied. So if you have 3 of them, what is it going to be called? So you have a lone pair, and then you have 3 atoms on it. It's called trigonal pyramidal. This is electron cloud. This is the answer. So how many lone pairs we have? We have just one lone pair. Okay. So I'm going to stop here. I'm going to go, this is the 15 minutes. I'm going to create another video here to continue on the rest of the molecules.